Hello Godotneers! In this third part of our G.U.I.D.E series, we'll explore how we can use G.U.I.D.E to create a settings dialog for our game, where the player can change the key bindings for the game. We'll explore how we can tell G.U.I.D.E which actions should be re-bindable, how we can display them in the user interface, and how we detect inputs and update the key bindings. We'll also have a look at how we can detect and handle conflicts between the key bindings. And finally, we're looking into how we can save these key bindings to a file and load them again when the game starts. Like the previous videos, this is an intermediate level tutorial. To make the most out of it, you should already know your way around Godot. So you should know the basic features of Godot like nodes, scenes, signals, autoloads, and of course the GD script programming language. We're also going to work with UI components quite a bit, and we are not going to have time to explain the UI basics. So if you need a refresher on UI basics in Godot, check out my UI video. Finally, this video builds on the first two parts of the G.U.I.D.E series, so it will be really helpful if you have watched those videos before. If you'd like to follow along with the video, you can download the example project we are using from GitHub. There's a link down in the description. G.U.I.D.E has received quite a few improvements since the last video, so in this video we are going to use the latest version of G.U.I.D.E that is currently available. If you follow along with your own project, make sure that you update G.U.I.D.E to the latest version. You can find a link to the update instructions in the description. G.U.I.D.E also had a breaking change, so make sure that you follow all the update instructions in the changelog. If you use the example project from GitHub, then your G.U.I.D.E version is already up to date and you can get started right away. So this is our project, as it has been at the end of the last video, and now we want to add a settings screen to our game where the player can change the key bindings. And to save some time, I have already created some of the parts that we're going to need for this. This scene contains our settings dialog, and right now there's not a lot in it. We have a tab container with two tabs, one for the keyboard and mouse, and a second one for the controller. Now, the idea for how this works is that we have sections in this dialog for each of the game modes, and within each section, we see the bindings for this game mode. I have already prepared some components that we can use for that. So here we have a section, and if I drag this into this container here, we can see that a section appears. And now I can set the title over here, for example, walk mode. And now the section will show this title. And now we can add bindings to this section. So I have another scene prepared here. We can now drag this input binding into the dialog. And then we can use the properties here on the side to set an action name and the key binding. And this is how we will build up our settings dialog. Now, of course, we don't want to do this manually for every single action. So let's delete these two nodes and then we can find a nice way to automate this. But before we get to this, I think we first need to add a way to open this dialog so we can see it in our game. So let's go over to our main scene. And then we need some place where we put our settings dialog. We already have layers here for our UI and the G.U.I.D.E debugger, so maybe let's add another one for our settings dialog. So Control A to add a new node, and then we pick a canvas layer, and we call this settings UI. And then we can drag our settings dialog scene into this layer. We also want to hide this dialog by default, so it doesn't show up when we start the game. And now we want to open this dialog in our game with the escape key or the start button of our controller, because these are the key bindings that most games use. Now, this is something that should be possible at any time in the game, so we want to create the bindings for this in our global mapping context. If we have a look at our input folder, we have the global mapping context for keyboard and mouse and the controller, which we have added in the last video. Now, to be a bit more organized, let's add a folder named global, and then we drag in everything that is global into this folder. Okay, now we can create an action to open up our settings dialog. So let's right click here, new, resource, and we pick a guide action. And we name this toggle settings dialog. So this action will toggle the dialog on and off. And now we can add a binding for this. So in our keyboard and mouse mapping context, we add a new mapping and we drag in the action. And then let's bind this to the escape key. Let's also add a release trigger, so the action only fires once when we let go of the key. Now we can do the same for the controller, so we add a new mapping, drag in the action, and bind it to the start button. And we also add a release trigger here. Okay, great. So now we can trigger this action in our game. So when we press this button, then we want two things to happen. First, the game should pause. And of course, we also want to show our settings dialog. Okay, let's do pausing the game first. So in the last video, we said that our world node here should control the game state. So I think it is a good place to add the pause logic in this node. Well, let's open up the script. And first we need a reference to our new toggle settings dialog action. And we can do this with another export var, toggle settings dialog, and this is a guide action. Okay, let's save this. And now we can drag our toggle settings dialog action into this new slot here in the inspector. So we have our action, and now we can use it in our ready function. So we can say toggle settings dialog, triggered, connect, and then we want to call a new function called toggle settings dialog. And we still need to create this one, so we make a new function, toggle settings dialog, and in here we just toggle the pause mode on and off. So get tree paused is not get tree paused. Okay, let's try this out. Let's fire some projectiles and then let's press escape and the game pauses. And if I press escape again, well, the game is running again. Really nice. Okay, so now we can show our dialog. And this dialog can actually control itself. So the world node doesn't really need to know about our dialog. So let's open up the script for our settings dialog. And here we add another export variable for our toggle settings dialog action. So export var toggle settings dialog. This is a guide action. And then we save this. We drag in the toggle settings dialog action. And now we can connect this action to a function in our ready function. So we say toggle settings dialog, triggered, connect, toggle visibility. And we don't have this function right now, so we make a new one. So func, toggle visibility. And inside of there, we can just toggle the visible flag. So visible is not visible. Okay, let's try this out. If I press escape, the game pauses and our settings dialog shows up. And if I press it again, then the game continues and the dialog disappears. Let's show the dialog again. And we have a little problem here. Our mouse doesn't really show, so we cannot control our dialog. Now, in the last video, we have created this input manager node. And this node is responsible for showing and hiding the mouse depending on which game mode we are in. So let's open up the script for this node and then we can see how we can show our mouse when we have this dialog open. So here we have the code from our last video, which looks at the game mode and the input mode. And then it enables our mapping contexts and shows and hides the mouse. Now with our settings dialog, we need to change this a bit. So when we show our settings dialog, we want to disable all the mapping contexts except the global one. And we also want to show the mouse cursor if we currently use a keyboard and mouse. Now we could say that the settings dialog is just another game mode like build mode and walk mode, but then we will need to keep track of which mode was active when we open the settings dialog, and then we need to restore this when we close the settings dialog. And that is a bit too complicated. So I think it's easier to just have a flag that tells us whether the settings dialog is currently open. So let's add a new variable to track this. So we say var in settings, this is a boolean, and we initialize this to false. And we of course also need access to our toggle settings dialog action. So we add another export for this. So export var toggle settings dialog. This is a guide action. And then we save this and we drag in our toggle settings dialog action into the inspector. And now in our ready function, we listen to this action. So toggle settings dialog triggered, connect, and then we call a new function, toggle settings. Okay, let's add this new function. And this really does nothing special. It just changes our flag that we have added that tells us whether or not we are in the settings dialog. So in settings is not in settings. And then we just call the update input function, which we already have down here. And we put the code that shows or hides the mouse into this update input function, because then it's at the same place as the other code that controls whether or not we see the mouse. So now if we are in keyboard and mouse mode, we want to show the mouse cursor when the settings are currently visible. So we can leave most of this code as it is, and just here, after we have enabled our global mapping context, we can add a check. So if we are in settings, then we can show the mouse, and we copy this line from here. And then we return because we don't want to enable the other mapping context. And for the controller, well, this is pretty much the same. So down here, we add another check if we are in settings. And in this case, because the mouse isn't visible with the controller anyway, we can just return here. So now when we press the escape key, then this toggle settings function is called. And this sets the in settings variable to true. And then it calls update input. And now update input shows the mouse when we're using keyboard and mouse. And also disables everything but the global mapping context. So we don't get any game input while we're in the settings dialog. And if we press escape again, then toggle settings is called again. It sets in settings to false, and then again calls update input, which will re-enable the mapping context so the player can play the game again. And all of this is nicely contained, so the rest of the game doesn't need to know about it. So let's give this a try. Let's use keyboard and mouse to move around. And then we press escape, and our mouse cursor is visible, and we can use it to control our dialog. And if we press escape again, well, we return to the game and our control scheme is restored. Now we can show and hide our settings dialog, so we can begin to actually implement the remapping. So let's open up the settings dialog, and then let's think about how we can make this happen. In the beginning, we did a little mock-up of our dialog where we said that we want to have the actions split by input type and game mode. So on each tab, we want to show a section for each game mode, and this should list the controls for this game mode. So now we would need to know which actions we can actually remap and which of them are used in which mapping context and to which input they are currently bound, because we need all this information to render our dialog. Now, that's quite a lot of moving parts that we need to control here. And to help with that, G.U.I.D.E comes with a built-in class called the G.U.I.D.E remapper. And this class can do most of the heavy lifting for us. So let's create a variable up here, and we call var remapper. And that's a G.U.I.D.E remapper. And we initialize this to G.U.I.D.E remapper.new. Now, before the remapper can do anything, we need to initialize it. So let's go here into our toggle visibility function. And this function is called when we show the dialog and when we hide the dialog. And we can use this visible flag to determine whether we have just been shown or hidden. So if we have just been hidden, then we don't need to do anything else right now. So we can just add a line here that handles this part. So if not visible, then we just return. Now we know that our dialog just became visible and we can initialize our remapper. So we call remapper.initialize. And if we now look into the autocomplete, we can see that this function expects a list of mapping contexts and a thing called G.U.I.D.E remapping config. Well, let's first start with the mapping contexts. Here we need an array of all the mapping contexts which may contain actions that we want to remap. So for our game, we have 6 mapping contexts. We have the global context for keyboard and mouse. We have the walk mode context for keyboard and mouse. And we have the build mode context for keyboard and mouse. Now we can put all of these into an array and we give them to the remapper. So we open an array and then we put all these mapping contexts into this array. Now, the remapper also needs a second argument for this function, which is called a G.U.I.D.E remapping config. And this is a class that stores all of our changed mappings. And later we can use this class to save our changed controls to a settings file and then load it back when the game starts. So let's create a variable, var remapping config. This is a G.U.I.D.E remapping config, and we initialize this with G.U.I.D.E remapping config.new. And then we can give this as a second argument to our initialize function. And now we can save the script and quickly drag in our mapping context, and we have an initialized remapper. But what can we do with this? Well, we can now ask the remapper about actions that we can bind. So we can say, remapper get remappable items. And this will return a list of all the things that we can remap. And this is really nice because it keeps up to date when we add new actions to our game. But how does the remapper actually know which of these actions we can remap? Because after all, there are some actions we don't want the player to remap. For example, the key for opening the settings dialog. To tell the remapper what we want, we have some configuration flags on the action. Now let's double click on our shoot action here. And now in the inspector, we can see that this has an action remapping section here. And there's a flag here, is remappable, and we can check this to make an action remappable. And we have also settings for display name and display category. And this way we can show a nice readable name to our player. So for our shoot action, let's enable the is remappable, and then we set the display name to shoot. And we could set the category to something, but we don't need this right now. So I'm going to leave it empty. So let's see if we actually get our action back. So let's create a variable that stores the results from the remapper. Var items, this is an array of G.U.I.D.E remapper.config item. And we initialize this with remapper get remappable items. And now we can walk over this array and just print what we got. So for item in items, and then we can just print the display name of the item. Okay, let's start the game and open our dialog. And we can see our shoot action right here in the console. But it is printed twice. Why is that? Well, it is printed twice because we have actually 2 bindings for this action. There's one binding in our walk mode keyboard and mouse mapping context, and the second one in our walk mode controller mapping context. And because of this, the remapper will give us 2 items, so we can remap each one separately. So that seems to work great. So let's quickly go over the other actions in walk mode. We have the move action. So let's make this re-bindable and we call it move. We have rotate camera and rotate player. I don't think it makes a lot of sense to make these remappable for our game, so we skip these. Finally, we have switch to build mode, and this one we can make re-bindable again. So we tick the checkbox and we set the name to switch to build mode. And then let's run the game again and see if our changes show up. And now we have move showing up 5 times, then shoot 2 times, and switch to build mode also 2 times. The switch to build mode action looks okay because it also has 2 bindings, one for the controller and one for the keyboard and mouse. But what is going on with the move action showing up 5 times? Well, let's have a look at our mapping context for walk mode and keyboard and mouse. And here we can see that our move action is actually bound to 4 different keys, W, A, S, D. And because we can rebind each of these keys separately, the remapper produces 4 items, 1 for each key. And the 5th item is from our controller binding for the move action. But it's not really great that our keyboard bindings are all labeled with move. And it would be really useful if we could have separate labels in our binding dialog for each of these keys. So how can we fix this? Well, if we look at our key binding here, there's a little setup icon on the left. And if we click this, we can override the settings of our action for this particular binding. So we can check this override action settings checkbox here. And now we can again say if this key should be remappable and what the display name and category should be for this binding. So we want this to be remappable, so we tick the checkbox and we set the display name to forward. And now we can do the same thing for the other 3 bindings. And now if we start the game again, we get forward, backward, left, and right. Okay, now we can get a list of the things to bind and we can start making a UI for this. So let's go back to our settings dialog. And if we look at the tree, we can see that there are 2 containers, one for the keyboard and mouse and one for the controller. And we want to add UI elements for all the re-bindable items into these containers. So let's make a function that can add all remappable items of a mapping context into a UI container. And this way we can just call this function a couple of times, fill in the items of our mapping context, and we're done. So let's call it build section, and this takes a container, which is the container that we want to fill. It takes a title, which is the kind of section title that we want to have, and it gets the mapping context, which we can use to get all the remappable actions for this mapping context. And now we can move these lines where we get the items and the loop into this function. And we need to change this call to remapper get remappable items mapping context. So now this will only return the items from this mapping context. Okay, now we have all the items that we want to display, so it's time to build up some UI elements. In the beginning, we already had a quick look at some of the elements that we're going to use. So if we look into our UI folder, we have an input section and an input binding. Well, let's start with the bindings. So this is how it looks on the inside. It has a title label and a bound input rich text label. And if we look at the script, we can see that it has 2 properties to which we can set the title and the bound input text. And then the script will take care of updating our UI elements. So this is a really simple thing. And back to our dialog, we need this scene in our script. So let's drag it up in here and we get a constant. Well, let's rename this to input binding scene. And let's add a type hint, which is packed scene. And because we use preload here, we can also make the path relative, which is a bit easier to read. If we were on Godot 4.4, we could also use a G.U.I.D.E for this, which is a bit more robust. But this project was started on 4.2, so we have to make do with the path. Now we can instantiate the scene in our for loop down here. So let's create a variable var input binding. This is an input binding. And we instantiate our input binding scene. And now we can use the properties that we have just seen. And we set the title to item display name. And the bound input, we keep empty for now. Now we would need to format the input that is currently bound to this item so we can show it in our input binding. In the previous video, we learned about the G.U.I.D.E input formatter, and we can use this as well for our binding dialog. So let's create a new G.U.I.D.E input formatter that we can use. So up here, we add a new variable, var, G.U.I.D.E input formatter. That's a G.U.I.D.E input formatter. And we initialize this with G.U.I.D.E input formatter new. And now we can format our input. But how do we know which input is currently bound to the item? Well, we can ask our remapper. So we can write var input. This is a guide input. And we ask our remapper, get bound input or null of item. Now we have the input that is currently bound to this item, and we can format it. In the previous video, we always gave actions to the formatter, but the formatter can also format guide inputs directly. So we can write input formatter, input as rich text async, input. And this async gives us a hint that this is a function that will take a few frames to work. So we need to add an await in front of it. Okay, so now we have our UI element set up and we can add it to our container. So container add child input binding. Now we only need to add a title row. This is another UI component that I have already prepared. So we can drag this input section scene from our UI folder into the script. We rename it to input section scene. We add a type hint of packed scene. And we also use a relative path here to keep things a bit more readable. Now we can go back to our function and create a section UI element. So var input section, this is input section instantiate. And then this works pretty much the same way as with the binding. We set a title, and this is the title that we get in as a parameter of this function. And we add this as a child to the container. Okay, now we have a function that creates UI sections from mapping context. So we can just call this a few times to build up all the sections that we need. We still need access to our two containers here in the tree. So let's drag them in and rename them. And now we can use them in our toggle visibility function. So we call build section, keyboard and mouse container, walking, walk mode, keyboard and mouse. So this will build the UI for all bindable input for keyboard and mouse in walk mode and add it to this keyboard and mouse container. And now we can do the same thing for the other mapping contexts. So we build a section for build mode and keyboard and mouse, for walk mode and controller, and for build mode and controller. So this was a lot of setup. So let's try out if this actually works. We start the game, we press escape, and that doesn't look too bad. We see all the bindable items that we have configured, and we have their bound input next to them. And if we switch over to the controller tab, we can see that it works there as well. And we can also see that the move action here is just a single entry instead of 4, because for controllers, this is bound to a single input. And all of this is automatically handled by the remapper, so our UI code stays really nice and simple. Now, these icons are a bit too small, but we can fix this up here where we create the input formatter. We can give this a desired icon size in the constructor. So let's maybe go with 48 here, and let's try this again. And this looks better. Great. Now, we still don't have anything here in the build mode section, and that's because we haven't set up our actions yet. So let's go back to our input folder into build mode, and then let's see what actions we would like to remap. I think the place tower action would be okay. So we take the is remappable checkbox and set the display name to place tower. The select tower is also a good candidate. Maybe cancel tower placement. And of course, we also want to switch back to walk mode. Okay, let's start the game again. Press escape. And our actions now nicely show up here without any code change. And again, on the controller tab, all of these new actions have also been added. Now let's say we don't want to be able to rebind move for the controller, because it should always be the left stick. How would we do that? Well, let's go back to our controller walk mode mapping context. And then we click this override button here and tick the override action settings here in the inspector. Now we don't set this is remappable flag, and this way the action will not be remappable when it's used in the controller mapping context. So let's start the game and see if that works. And if we go over here to the controller, we can see that the move entry has disappeared. But it is still here on the keyboard and mouse tab. So for keyboard and mouse, we can still bind this to something else. Great, so now we have a basic settings dialog running, but we still cannot rebind anything. So let's have a look at how we can actually rebind stuff. To rebind something, we would like to click here on the label, and then some dialog should open that lets us rebind the key to something else. So this part of the dialog that we would want to click is built with our input binding scene. So let's have a look into this one. And here we have a title label and our bound input rich text label. And now we would like to know when someone clicks on this label. Now we can of course detect the mouse input on our label, but we also want to control this UI with a controller later. So if we use a label, then we cannot focus on it with a controller. So maybe it's a better idea if we use a button instead of a label. So let's delete this label and then Control A to add a new button. And we name this title button, and we make it a scene unique name so it's easier to reference in our script. Let's add some text to the button. Some text here. And now this button should be transparent. So let's click this flat setting here, and now it has no background anymore. We also need to set up the layout. So we set the horizontal layout to expand. So the button takes half of the available space. And we set the sizing to shrink end so it aligns to the middle. For the vertical spacing, we set the sizing to shrink center. Now we can move over to our code for this little component, and we change the title label up here to be a button. So we can leave the property which sets the title as it is, but we still need to notify our settings dialog when someone clicks on this new button that we have added. So let's add a signal for this. A signal, binding change requested. And now in our ready function, we connect to the button's press signal. And when this happens, we emit our binding change requested signal. Okay, let's start the game again and see if we get our buttons. We press escape, and now we have the buttons here where we had a label before. And if I switch over to the controller, I can also navigate these buttons with my controller's left stick. So now when the player clicks on the button, we would like to show a little dialog that tells the player to press the new input that should be bound. We don't have this little dialog right now, so let's go back to our settings dialog scene and add some user interface for that. So this new input prompt, if you will, should be rendered on top of everything else. So we add another margin container. Let's name it input prompt. And we make this a scene unique node, so we can later access it from our script. And let's also set the mouse filter to stop, so we cannot click through this and accidentally click on our UI while this is showing. Now we need a few more containers, so let's add a center container. Inside of that, we put a panel container. And inside of that, we put a margin container. And inside of that, we put a label. Now let's set the labels text to something like actuate the control now. And this looks pretty terrible, so let's make it look a bit less terrible. So for the label, we use the header large theme type. And for this panel container, let's override the style. And let's use a style box flat and maybe go with some dark gray that is not transparent. Now I would like to have a bit more space around the label, and that is what this margin container is for. So we go with 100 for left, 50 for top, 100 for right, and 50 for the bottom. It still doesn't look great, but we still have a lot of stuff ahead of us, so that's good enough for now. Okay, now we can hide this input prompt because we only want to show it when the player tries to rebind a control. And now we can go into our code and use this. Let's first drag it in so we can then use it. And now in our build section function, we have our loop here where we create our input binding components. And we can listen to the binding change requested signal that we have added a few minutes ago. So input binding change requested, connect, and we will call a new function on binding change requested. And of course, we still need to add this function. So func on binding change requested. And for now, just let's make the input prompt visible. Well, let's try it out. We start the game, press escape, and click on one of the buttons, and our prompt shows up. Okay, that works great. And now we need to somehow detect the input of the player. So how can we detect the input? Well, detecting raw input in Godot isn't too hard. We could just write a function like func_input, and that gives us some input events. And now Godot would call this function whenever some input is actuated. But actually, we need to do quite a bit more. First off, we're only interested in the input when our input prompt is open. Then we only want the input from a certain device. So if we do a controller input binding, we only want controller input. Also, the input should match the type of control that we want to bind. So if we want to bind to a Boolean action, the player shouldn't be able to bind an axis to it. And these requirements are pretty much true for every kind of game. And that is why G.U.I.D.E ships with a custom node that handles all of these things for us. So let's delete this input function and instead use the node. So we press Ctrl A to add a new node, and we look for a G.U.I.D.E input detector. Well, let's rename it to just input detector, and we make it a scene unique node, and we drag it into our code. And now down here in our onBinding change requested function, we can call input detector detect. If we look at the autocomplete hint, we can see that this function expects a value type. The detector needs to know what kind of input it should detect. Should it detect a button press or an axis or maybe even a 2D axis? But right now we don't have any value type that we could put in here, because that depends on which binding the player wants to change. So where can we get this information from? Well, when we build up our input bindings here, we get a list of remappable items from our remapper. And each item contains all the information that we need to do the remapping. So we can give this item as a parameter to our onBinding change requested function. So in our connect, we just add a bind item to our function name, and this will give this item as a parameter when this onBinding change requested function is called. And down here in our function, we add a new parameter, item. This is a G.U.I.D.E remapper config item, and now we can get the value directly from the item. So we can call input detector detect, and then item value type. So now our detector will only detect input that matches the value type for this binding. So if we try to bind a Boolean input, it will not try to detect any controller sticks or the mouse movement or anything that is basically not a button. This is nice, but how do we get the information which input our detector has detected? Well, the player may need a second or two to actuate the input, so we need to wait for this to happen. And because of this, the input detector has a signal named input detected. The detector will emit this signal when it detects input or when the player aborts the input detection. We'll look at aborting this process later. For now, let's focus on getting the detected input. Now, a very simple way to wait for this signal is to use GDScript's await keyword. So we can write var detected input. This is a guide input. And this is await input detector input detected. So this will wait for a detection to happen and then give us the detected input right back. So then we can hide the input prompt. So input prompt visible is false. And for now, let's just print out which input we have detected. So print detected input. And let's start the game to see if it works. So we open the dialog and then let's try to rebind this key. And our prompt shows, and now if I press the B key, the input prompt disappears and we can see our detected input is printed here in the console. So we now have our new key, but we still need to change the mapping. So how do we do that? Well, there's a function in the remapper that can help us. We can call remapper set bound input. And now we can see in the autocomplete that we need a config item, which we have here, and the new input, which we have here. So let's put these in. So set bound input, item, detected input. And that should take care of remapping the input. So let's try this out. And let's maybe bind forward to B. Okay, our print is showing and the code seems to have worked, but our dialog doesn't update. And of course it cannot update because the UI doesn't know that we have changed some binding. So now how do we update the dialog? Well, we could clear out our two containers and then rebuild everything, but that's a bit excessive. So I think it would be nicer if we could just update the item that needs to change. And G.U.I.D.E has something built in for this case as well. So these items that we get from the remapper, they have a built-in signal that is emitted whenever the input binding for this item changes. So let's first make a function that can update an input binding UI item. So func update bound input. This takes an input, which is a guide input, and a binding, which is our input binding UI element. And in this function, we just want to update the input that is rendered as part of this input binding UI element. So we say binding bound input, and this is await input formatter input as rich text async input. And now up here, instead of calling the input formatter, we can just call our new function. So we say update bound input, input binding. So this will do the same thing as before. We just moved this line into a separate function. But now we can listen to the change signal of our item here. And if we look into the code, we can see that this signal gives us the new input as a parameter. So we can call item changed connect, update bound input, bind, input binding. So whenever the item changes, the update bound input function is called with the new input as the first parameter, and our bind call here adds the input binding UI element as the second parameter. So let's see if that works. We start the game and then let's try to bind forward to B, and our UI nicely updates. Now what happens if we try to bind backward to B as well? Oh, well, that's not good. We really don't want to have the same key bound to two different actions, so we need to handle this somehow. So how can we find out that our new input will collide with some existing binding? Well, we can ask our remapper. So we can create a variable, collisions. This is an array of guide remapper config item. And then we call remapper get input collisions. And we give it the config item that we are trying to bind and the new input that we have detected. So now the remapper will return all config items which are currently bound to the same input. For now, let's just print out all the colliding items. For collision, this is a guide remapper config item in collisions, print, collision, display name. Now let's start the game. And in the dialog, we try to bind forward to A. And now we can see that the remapper found out that this collides with the left action. Okay, this is great, but what are we going to do about this? Well, many games just unbind any other binding that uses the same input. We could also just show a dialog that is asking the user about this, but this video is already quite long and we still have a bit of things to do, so let's keep it simple here. So in our code, we can just say remapper, set bound input, collision, null. If we set the bound input to null, this will unbind any input from the colliding input bindings. So our collision handling rules are now, if a collision occurs, then unbind the colliding binding and then apply the new binding. Okay, let's try this again. When we try to bind forward to A, then our new code will unbind A from the left action. And because our UI listens to the signal whenever a config item changes, both of our UI input bindings now update. So forward shows A and left shows the empty string because it's not bound to anything anymore. Well, that's great. Now let's try another thing. Let's try to change the switch to build mode action to F. And that works. Well, let's also try to change the switch to walk mode action to F. Now we have a problem because these two actions use the same key. And in some games that might be a real problem, but in our game it isn't, because for our game we know that build mode and walk mode can never be active at the same time. So it's not a problem if these two things are bound to the same key. So we would need to change our collision handling rules a bit. If a collision occurs and it is in the same mapping context, then unbind the colliding binding. And after this, apply the new binding. So how do we handle this? Well, the collisions that our remapper gives us are just a list of config items. So we could write if item context does not equal collision context, and then we just continue. So if the mapping context of the item that we want to change is different from the one that collides, we can just ignore the collision. Okay, let's try that again. If I bind right to Q now, the switch to build mode action is unbound because it is in the same mapping context. But the switch to walk mode action stays bound to Q, and this is how it should work for our game. This is nice, but we still have a bug in here. In build mode, we use the WASD keys for our camera movement. And right now, these keys are not bindable. So what happens if I map the select tower action in build mode to the W key? Well, that seems to work. But if we look into our debugger tab, we can see that we get an error message here, and that says, given action is not remappable. If we expand this, we can see that this comes from our line here where we try to set the binding to null. So what happens is we try to unbind camera movement, which is not bindable, and the remapper is preventing this. So now we have the W key bound to two actions, which isn't great. So we need to change our collision handling rules again. If a collision occurs and it is in the same mapping context, then unbind the colliding binding and then apply the new binding, but only if the colliding item is remappable. If this is not remappable, then we need to abort the whole binding process. So how can we know if an item is remappable? Well, the config item also has a property is remappable that can give us this information. So we can write if not collision is remappable, return. Well, let's try this out. We try to remap the select tower action to W, which should not work because W is already used for camera control and cannot be rebound. And this time, everything stays as it is, and we get no more error messages. Great. So, have we handled all the cases now? Well, not yet. There's another way in which we can break this. Let's go over to the controller part and try to rebind the fire action to the play button of the controller. This works, and no collision was detected at all. But we use the play button in our global controller mapping to toggle the settings dialog. So the player should not be able to bind this. So we still have an open spot in our collision handling rules, and if we look at the diagram, we can see this. We try to bind the fire action from our walk mode mapping context, but our collision is in the global mapping context. So we now go this way and directly skip to apply the new binding. So we need to add another check in here. So if collision context is the global keyboard and mouse context, or the collision context is the global controller context, then we return as well. Well, let's try this again. And now if I try to bind the fire action to the play button, the binding is aborted and everything else stays as it was. So we can see that collision handling can become quite tricky depending on how our game works. But because we get a lot of information from our remapper, we can handle these cases with just a few lines of code. Now let's try something else. What happens if I go back to the keyboard and mouse tab and try to bind the forward action to a controller key? Well, it seems to work just fine, but for our game, we really don't want this. We only want to be able to bind keyboard and mouse inputs on this tab, and only controller inputs on the controller tab. So how can we fix that? Well, we can tell the input detector which kind of device it should listen to. So let's create a variable which holds the devices for which we want to detect input. So var devices, this is an array of guide input detector device type, and we initialize this with an empty array. So now we can look at our item that we get here and check in which mapping context is it. So if the item context is build mode keyboard and mouse, or if it is walk mode keyboard and mouse, then we only want to detect keyboard and mouse. So we say devices is guide input detector, device type keyboard, and guide input detector, device type mouse. And otherwise, well, we don't have keyboard and mouse, then only controller is left, so we can set the devices to guide input detector, device type G.U.I.D.E. And then we can tell our input detector which devices it should detect as a second parameter to our detect function here. So we just add devices. Well, let's try this out. And in our keyboard and mouse section, let's try to rebind the forward key. So if I now press a button on my controller, then nothing happens because the input detector will only listen to keyboard and mouse input. But if I press, say, the C button, then it's detected nicely. And if we go over to the controller section and try to change the shoot action to, say, the left mouse button, well, nothing happens. But if I press the A button, this works. So the input detector really gives us a lot of flexibility, and we can only detect what makes sense for our game right now. That's great, but we still have another case to handle. Let's switch over to keyboard and mouse again, and let's try to bind forward back to W. Now let's say we accidentally click the left instead of the forward setting. Now we have this pop-up, and we need to rebind the key for left, but we really don't want this. So we need a way of aborting the detection. In most games, you can press the escape key or the back button on your controller to abort a detection. And if we press escape right now, our code will abort the detection. But that is just a happy accident because we have just added some lines that we abort the remapping if the key collides with something in the global mapping context. So we could call it a day here, but what if we wanted to have a dedicated key to abort the remapping? Let's say we want the backspace key to abort the detection. If I try to bind left again and press the backspace key, backspace is now the new binding for the left action. So how can we have a dedicated abort key? Well, the detector has a setting for this. If we click on the detector, we can see a setting here, abort detection on. And here we can define some inputs that should abort the detection. So we want to abort the detection on backspace. So let's add a guide input key here. And we set the key to backspace. Now that fixes it for keyboard and mouse, but if the player wants to use a controller, well, they cannot really press the backspace key. So we need another input for when the player is using the controller. Well, let's use the controller's back button for this. So we add a guide input joy button and we select the back button here. Okay. Now, how do we know in our code that the player has aborted the input detection? Well, here we wait for the input detected signal, and this signal will still come even if the player has aborted the detection. But if the player has aborted the detection, then this signal will return a null input because nothing was detected. So after we have closed our input prompt here, we can just check if the input was null. So if detected input equals null, and if this is the case, we can just end the function here. So we return. Okay, so let's try to rebind forward. And now if I press backspace, then the detection is aborted. Nice. Let's see if this also works for the controller. So let's try to rebind the shoot control. And if I press the back button, then the detection is also aborted. Well, that's great, but our dialog still has quite a few rough edges. Right now, we cannot really control this dialog with a controller. So whenever I want to rebind a control, I need the mouse to click on it. So let's make this dialog a bit more controller friendly. So let's see where the problems are. Let's exit the dialog and switch to the controller. And then let's press the play button to open the dialog again. And we're immediately stuck. Because no UI control is focused, and without focused controls, we cannot really do navigation with the controller. So how can we fix this? Well, as a first step, we could let the dialog automatically switch to the correct tab. So if we open this with the controller, it should switch to the controller tab. And if we open this with keyboard and mouse, then it should switch to the keyboard and mouse tab. Now, how do we find out which kind of device we use to open the dialog? We just have our toggle settings dialog action that we created in the beginning, and the actions don't know which input triggered them. But if we go back to our input manager's update input function, we can see that whenever we open the settings dialog with keyboard and mouse, the global keyboard and mouse mapping context is active. And if we open it with the controller, then the global controller mapping context is active. So we can check which mapping context is currently active and then set the correct tab. So let's go back to our settings dialog, and in our toggle visibility function, directly after our visibility check, let's add some code to switch the tab. So if we currently use the keyboard and mouse, so guide is mapping context enable, global keyboard and mouse, then we select the first tab, so tab container, current tab is 0. And otherwise, we select the second tab, so tab container, current tab is 1. We also need to make sure that the tab has focus so the controller can navigate it. So let's write tab container, get tab bar, grab focus. Okay, let's see if that makes it better. We start the game. And if I now open the dialog with the controller, we can see that the controller tab is selected and it's also focused. So now I can use the left controller stick to navigate the UI. But why does this actually work? We didn't add anything to our mapping contexts to navigate our UI with the controller, and we certainly didn't write any code for this, so why does it work? Well, Godot has built-in support for this, so we get this functionality for free. And this is really nice. So let's see if we can actually rebind a control here. Let's go to shoot and then press, well, let's try A. It doesn't work. So let's try some other buttons. Well, none of them seem to work. So it looks like we have to do some work after all. So where can we configure this built-in controller support for Godot's UI system? Well, all of this is configured in the input map. Let's open it up with Project, Settings, Input Map. And this is quite empty. But if we toggle the Show Built-in Actions button up here, we can see that Godot has quite a few built-in actions. And all these built-in actions are the default bindings for Godot's UI system. So if we scroll a bit down here, we can see that there are a few actions named UI left, UI right, UI up, and UI down. And these are bound to the left stick of the controller by default. So whenever we move the stick, Godot will emit these actions, and then Godot's UI will react to them. Okay, that is great. So where can we add our binding for clicking a button? Well, if we scroll up again, we have an action UI accept. And this action is used to click the UI item which is currently in focus. Right now, we can see it is bound to the Enter and Space buttons on the keyboard. So we could just add another binding here. And we select joypad buttons, joypad button 0, which is the A key on the Xbox controller. Okay, let's close this and try again. We open the dialog, move to shoot, press A, and our prompt activates, and we can now rebind this control without having to use a mouse. Now we saw that Godot's UI system is controlled by the built-in action mapping, but we have all our game controls mapped in G.U.I.D.E. So wouldn't it be better if we had everything in G.U.I.D.E? Can we even have everything in G.U.I.D.E? Well, we certainly can. Let's say we wanted to control the UI accept through G.U.I.D.E rather than the built-in system. Well, we can create a new action. So right-click, New Resource, G.U.I.D.E action. And let's name it UI accept. And then let's open this up in the inspector. And now we give this action a name, UI accept, and select this Emit as Godot Actions checkbox here. And then we can open up our global controller mapping context, add a row, drag the action in, and bind this to the A button of the controller. And let's also add a press trigger, so this triggers only once for each button press. So we have set up the action, and now we could go to the project settings and remove our A button mapping from the UI accept action. Well, let's try it out and see if that works. We open the dialog, and let's try to rebind firing. And this works nicely. So we certainly could do this in G.U.I.D.E. However, I think this is not really worth the effort. We would need to create a lot of actions and bindings only to achieve the same thing that is already built into Godot. So let's remove this action from our mapping context, and we add the binding again to Godot's built-in action mapping. And this way we get the best of both worlds. We get a working UI for free from Godot, and we get all the benefits of G.U.I.D.E. for our own game-specific actions. Okay. So now we have good controller support for our settings dialog, and we can rebind the controls any way we like. But right now, all of this just happens in the dialog. Our game doesn't use this new configuration, and it's also not saved. So if we close the game and reopen it, all changes are gone. So let's fix that. I think it's a good idea if we store the updated bindings when the dialog is closed. So let's go to our toggle visibility function. And here we already have the if that checks if the dialog becomes invisible. I think this is a great place to put our saving code. So how do we get the new configuration? Well, we can ask our remapper. So we say var new config. This is a G.U.I.D.E remapping config. And this is remapper get mapping config. So now we have the updated bindings in our variable, and we can tell G.U.I.D.E to use these updated bindings with G.U.I.D.E set remapping config new config. So now when we close the dialog, G.U.I.D.E will use our new bindings. Well, let's try this out. And let's rebind fire to the E key, leave the dialog, and we can see that our prompt up here is already updated. And if we press the E key, then Mr. G fires his magic bolts. That works great, and we didn't even need to change anything else in the game. Now we only need to save these new bindings and load them when the game starts. I think this should probably go into its own helper script, so we can access the functionality from the dialog and also from our main game. So let's go to the input folder and let's create a new script. We call this remapping configuration.gd. And this helper will save and load our remapping configuration for us. So first let's give it a class name. So we call it remapping configuration. And then we need a function to get the current remapping configuration. So static func get current. This returns a guide remapping config. And right now we return a null. And another one that stores the remapping configuration. So static func save new config. And this is a guide remapping config. And for now we pass. So let's start with the saving. This is pretty easy because guide remapping config is a resource type. So we can just save it with resource saver. So resource saver, save, new config, user remapping config, TRES. Now for loading, we will need the same path again. So I think it's better to move this into a constant. So let's create a constant up here, const save path. And then we just move this path up here in the constant and use the constant down here. Okay, that was saving. Let's do the loading. And here we have two cases. If the player has never changed their settings, we don't have a saved remapping config. So we need to check for that. So we ask the resource loader, if not resource loader exists save path. And if the resource does not exist, we just return a guide remapping config new. And otherwise, we load the saved configuration. So resource loader, load, save path. And we can use an empty string for the type hint. So Godot will figure out the type automatically. And finally, we use cache mode ignore. So we make sure that we always load the latest saved version from the disk and we don't use any cached version. So that was saving and loading. And now we just need to make sure that our game loads this saved mapping configuration when it starts. I think a good place to do this is the input manager node. So here in our ready function in the input manager node, we can apply the remapping just like we did in our settings dialog. So we can say guide set remapping config, and then we call remapping configuration get current. And finally, we also need to make sure that our settings dialog reads and writes this configuration. So let's move over there one last time. First, when we close the dialog, before we apply the changed configuration to guide, let's save it. So remapping configuration save, new config. And here, where we have created a new mapping config, we just read the last saved one from the disk. So remapping configuration get current. And that should do it. Let's give this a try. We open the settings dialog and maybe let's bind shooting to the spacebar. We close the dialog. Our new binding is now active and we can shoot with the spacebar. Well, let's close the game and reopen it. And our changed binding is still active. In this video, we explored how we can add configurable key bindings to our game. We learned how to set up a simple UI dialog that allows us to rebind the inputs that trigger our game actions. We learned that we can mark actions as remappable, so we have full control over which game actions the player can rebind. We also learned that we can define separate binding names for actions that involve multiple inputs like the WASD keys. We learned that Guide provides the Guide Remapper class, which allows us to quickly find all remappable actions in our mapping context, and we use this information to add entries to our remapping dialog. We learned that we can use the Guide Input Detector node to detect input that matches our action, so that we only detect buttons for Boolean actions. We also learned And we can configure the device types for which input should be detected so that the player doesn't bind keyboard controls to our controller mappings. And we learned how we can configure inputs that will abort detection so our player can change their mind if they don't want to rebind an action. We learned that G.U.I.D.E Remapper can automatically find input binding conflicts, so we can make sure that each input only triggers one action, and we had a look at a few different approaches on how we can handle these conflicts. We also learned how we can make sure that our user interface automatically updates whenever we change an input binding. Finally, we had a look at how to apply the changed mappings to the game that is currently running, and how to save and restore these settings when the player restarts the game. I hope this video has been helpful. If you have any questions or suggestions on how G.U.I.D.E could be improved, please post them in the comments. If you liked this video, please give it a thumbs up and consider subscribing to the channel to get notified when new videos are posted. Thank you very much, and happy Godotneering!